Hi everyone, welcome back to CSM walkthroughs for EECS 16B. This is Jiu and this is week 3. We will be covering question 4, part A for this video. Okay, let's start. Uh, so assuming that you already had an intro on phasors, I will just continue with the problem. So here we first look at a problem where our input voltage is 10 volts. Well, 10 volts means that this is a DC current, a DC circuit. And what's important about this is that we can't use phasor analysis. This is because phasors takes into account that they have a frequency, namely omega. So we use this fact that that any voltage that are suitable for phasor analysis has an AC voltage, which means that they have some sinusoidal signal. And these are assumed whenever we use any phasor analysis. But in this case, we don't have any sinusoidal signal, so we can't use phasor analysis. So we should use our general circuit analysis. Here, you see that we have an inductor and a capacitor and an inductor. And we are given that the system is at steady state. Using this, we can actually simplify the circuit. How? Well, we know that at steady state, our capacitor, as this behavior of a capacitor reaches a steady state, that means our time t goes to infinity. And that means this part here goes to 0. So as a result, our voltage will approach 0. And if our voltage approaches 0, then no current is going through the capacitor, meaning it acts as an open circuit. This basically means no current goes through here and moves out of here. So we can basically ignore this segment. And now we will look at an inductor behavior. So similarly, as it reaches the steady state, this exponential part goes to 0. So this time, the current goes to 0. And when the current goes to 0, it basically means that it acts as a short circuit. Okay. So now we can simplify this as in this part, the current chooses the path where they don't have any resistance. So this is basically shorted. So no current goes through this. So this is basically shorted like that. I will simplify this as actually using a wire. Okay, this is a very simple circuit. So it should be easy to analyze it and solve for our V out. Well, if we look at this simplified version, we notice that this is a very basic form of a circuit, namely the voltage divider. So we use the formula for the voltage divider, which is just V out of T equals the total voltage, the total resistance on the denominator, and 1 ohm on the numerator. So that just gives us Vn over, so we're given Vn, that was 10 volts, so 10 volts over 3 ohms. Oh wait, no ohms. So now we solved for our V out, and that'd be all for part A.